continue our discussion on logic. In particular, we are discussing propositional logic, logical arguments or logical statements involving propositions. So we come across statements like this. If it is Monday, then it is not a holiday. If 2 plus 3 equals 5, then DSA is a key subject in CSE. If I work hard, then I score grade S in MOCS. Clearing gate is a necessary and sufficient condition to get MTech admission. So we come across statements of this type, not just simple statements like 2 plus 3 equals 5 or today is Monday. So we come across statements like this. So if you focus only on propositions, then this one is a proposition, this one is not a proposition. Then assuming clearing gate is a necessary and sufficient condition to get MTech admission, if I work hard, then I score grade S in this. So if you look at each of them, one can look at it in two ways. One, you can say the entire thing is a proposition. That's one way of looking at it. Another way you can also see like this one is a proposition, this one is a proposition, and it is combined using the operator if then. Okay. So similarly, this one is a proposition, this one is a proposition, and it is combined using the operator if then. Or you can also see it like the entire thing is proposition or entire thing is not a proposition and so on. And assuming, because we are in the context of propositional logic, if you assume a statement is a proposition, you can look at it in two ways. Either the entire statement itself as just one statement and it is a proposition, or it is a compound statement consisting of two propositions which are combined using the operator, in this case if then. Clearing gate is a proposition and getting MTech admission is a proposition, then the operator is necessary and sufficient. So not just this, it rains or I study. I study and I solve problems. And in this case, this one is an operator. In this case, this one is an operator combining two propositions. One is it rains is a proposition, another one I study, and I study here is a proposition, I solve problems is another proposition. So all this is telling you a larger message. For example, these two statements, there is no relation at all, and this one, for example, it rains or I study, there is no relation at all. But that's essentially what we are trying to convey. The abstraction, mathematical abstraction, focuses on a larger message and not giving importance to are these two statements indeed related, are these two statements indeed related. So that is not something we are concerned with. As long as this is a proposition and this one is a proposition, and combining using this operator, if it makes sense, then we talk about given the truth value of this, given the truth value of this, what is the truth value of this statement? So given the truth value of this statement, given the truth value of this statement, what is the truth value of the statement it rains or I study? So we don't really give importance to statement or proposition like clearing gate, I work hard, 2 plus 3 is 5, it is not a holiday, and so on. More than the statement, we are interested in the truth value. Okay, because we say so and so argument, yes, makes sense, there is a logic in it. So and so argument, we say no, there is no logic in it. So to talk about yes, there is a logic in it, there is no logic in it, what is actually deciding whether is there a logic in it or not, it is the truth value. So which means one has to focus on the truth value. So more than the statement, it is the truth value that is playing a role when we talk about the truth value of an argument. So when you extract this out, what do we get? We define something called propositional variables. So we denote using letters P, Q, R, S, T, and so on. So the propositional variable, it's a variable, so which means it can take many values. So this may refer the statement 2 plus 3 equals 5. This may refer the statement it rains. This may refer the statement 5 minus 3 is 11. So these are all propositional variables. It may represent any proposition. And now you have a proportional variable P, another proportional variable Q. What operators one can bring to combine them? What all logical operators one can talk about or one can bring in to combine two propositions? And subsequently we ask for given the truth value of this proposition and truth value of this proposition, what is the truth value of P, logical operator Q? So we shall see what all logical operators we come across in computer science, in particular the large applications that you come across in the field of computer science, and then how to prove the truth value of an argument through proportional variables and logical operators. So we are not really concerned with whether P is representing this or P is representing I work hard or clearing gate. We are only interested in the abstraction, so which means this picture will be converted into proportional variables, so something like P, Q, R, and then combine them using operators. So we shall discuss popular operators and then the truth value using the logical operators.